All right. Good morning, everybody. This is Andrew Holdsworth here again for the final last one of these web conferences or web sessions, whatever, to launch the videos that we've been placing up over the last few weeks associated with real-world performance. And we're going to try and make these events a monthly event. And what I have discovered is that a lot more people are listening to these events after the event rather than live. And whilst I really appreciate that, it would be really great if we could actually get some bigger live events and get more questions coming in. So one thing I'm going to ask is all the people who are on at the moment and the people who listen to us later, if you could let me know if there's a better time. I think end of the day on Friday is probably not a very good day for Europe, or time of day for Europe. It's probably not very good for Asia Pacific. It's probably okay for America, but is there a better time of day that we should organize these events, a different forum, and all feedback? And we're going to try and do a monthly event such that we can just get all the things that my team's been hitting. And also, we'd just like to get some feedback from everybody else. Have they tried techniques? Were they working? War stories, hero stories, whatever, as we go along. So, you know, basically this is the last of this current series. We want to do more, but I'd like to sort of tweak the format such that we get more participation and more communication back and forwards. So, let's get started. Well, I think anybody who's been coming to these sessions will know my philosophy and what we're about, and the concepts. As you can see, I don't really relax in my free time. I'm always trying to push the performance of something, either a boat or a bike or a car or something. And actually, yesterday I actually had a day off, and I actually went to the North Sales manufacturing facility up in Minden, Nevada, where they manufacture very high-tech racing sails, and even my boss's 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 boss, Larry, has been known to buy a few sails from them. But there was some interesting analogies that speaking to the designers and the manufacturers of those sails, the challenges that they face, very similar to the challenges that I face in my role. And we had a good little chat about this, but we came to this conclusion quite a lot, some of these conclusions quite together. Good performance is rarely an accident. I reinforce this over and over again. You get good performance through hard work, planning, a certain amount of talent, design, and rigor. You don't suddenly just put a boat together and it's flying high speed straight out off the dock. There usually has been some design work and some clever work done, and sometimes it just involves taking all the parts and making sure that they all work well together. The next one is something that certainly my colleagues and my team will all agree, because we've been grinning about this for the last couple of weeks, especially with regards to some systems that we have been having to look at, where people really do get the performance they deserve. We've seen a couple of sites where they realized they were out of their depth, they got help, and they immediately got better performance because they started fixing things and they took things on the chin. We've also seen a couple of sites that whenever we've made a suggestion to them, they basically argued and rejected it for non-technical reasons. And they're still experiencing bad performance. And it's kind of endemic in the performance space that very often people use non-technical reasons why they and excuses to get bad performance. So this was something I was taught by one of my mentors earlier in my career. People usually get the performance they deserve. And one thing I always aspire for is excellence. Never be satisfied with good enough performance. Always be trying to get the max out of the hardware you've got, and that would be fantastic. So that's pretty fundamentals of real-world performance, and it's sort of guided me for the last 25 years. Anyway, I thought we would have a little bit of a giggle. I found this one, I was pasted up on Facebook this week, and I thought, God, that's so analogous again to what we do in our real world life, is that I hear this term magic being used. Could you do some magic to our database? I don't know, who would like to get on an aeroplane being flown by magic? And I was trying to try and dream up a cartoon to redraw system design by magic. And I should probably make a dig at some of our product managers, because that's what some of their PowerPoints look like. But really, the reality is there is no magic. It's all just hard work and good engineering and good calculations and attention to detail, checking, peer review, getting all this sort of stuff. Not something, a discipline that has done much in the computer software industry, needed more. But the reality is there is no magic. It is an electronic computer. It works. It is predictable, can be made deterministic. Very often non-deterministic, because designs allow race conditions. But I just thought that was quite amusing to wake everybody up. Again, the big three problems that we see in real-world performance is the tools just don't get used very well. The wrong algorithms for the appropriate size of data set being worked on, and living with a legacy of people always trying to fix symptoms without understanding the problems. And I think I see 2 or 3 of those every day. This is why work is fun, because we see the same stuff every day, and we try and coach and mentor people into better ways to solve the problem. It's a daily basis. Okay, so let's talk about what the new videos we put up. Now, remember last week I talked about platform tuning and things like that we really didn't spend very much time on. But so I thought I'd contradict myself immediately. And 2 of the topics, which I'm going to do out of order, are related to platform setup and tuning or configuration, which we built 2 videos here, and these are usually the 2 things that get people hung up in terms of how they've configured their platform, and lead to the most either shaky performance or bad performance or unreliable performance. There's also been quite a lot of debate going on actually on the Oracle email list, and we'd like to sort of internally get this put to bed. In terms of use of huge pages, we have a video now up there that shows the impact of adding users, taking users, workloads coming onto a system. And in fact, what we do is we do it with 2 systems with identical workload being introduced to them, one with huge pages and one without. And you can see for yourself the impact on performance as and when memory gets exhausted. You'll also see the impact on the unpredictability of performance and the behavior. And this was kind of a nice demo to put together for us, because we went in with a very open mind and we didn't actually know what the right answers would be. However, what we have learned from escalations to our group, whenever somebody is working on Linux and they say the word memory, we immediately ask if they're using huge pages, and more often than not they say no, and the next day they have huge pages enabled, and then I don't hear from them again because all the problems have gone away. And so this is a really big topic if you're working with Linux. We, through building this demo, are absolutely convinced that huge pages should be enabled for your database on any Linux system. It's a little difficult to configure, it's a little bit iterative, it's a little bit painful. I'm not saying it's easy, but through the research we did on it, in particularly regards to predictability of the system, we're absolutely convinced that huge pages is the way to go for any type of database where memory may come under stress. And I'll let you watch the video and figure things out yourself. And the thing is, memory management on these systems are dynamic. So as memory gets allocated inside the Linux kernel, it's dynamic, and so it's fluctuating. And so the point where the system starts to swap and page out is undeterministic by the inputs you have around you. And this is really what's convinced us. We do see a marginal performance gain when you're not under memory stress, but really it's the predictability of the system that's really important. We've also included the log file sync demonstrations of the impact of what happens when you get slow log writes to the system, how it can basically stall out the entire database. And this is something we see particularly on SAN storage, where log files have been put on SAN storage and maybe sharing the same devices as other databases, other applications, all sorts of things on a corporate SAN. And at periods of time, those devices get overloaded, and as a result, the log file sync or the log file write times degrade, which has then a corollary, because the log file sync is a function of the time waiting for the write, and we see a high log file sync as a percentage of wait event. So something to really study. Those are probably the two biggest platform issues we see generically, and it can be configured out and designed out. And it comes back to that point that you can basically get good performance out of the box if you configure these from the beginning rather than having to do it reactively. So good stuff. Hope you enjoy them. And then the last one, which was the one at the top, we hinted on 2 weeks ago about CPU oversubscription or overprocessing. And this is basically mean running more processes than there are cores on the machines. And this is a very common problem with Oracle databases, particularly systems that have been historically I/O bound, and then suddenly they've either upgraded the I/O subsystem or increased the buffer cache size so everything's in memory, and suddenly a lot of processes become runnable. And the point where there's more processes runnable than the number of cores on the system, we're into oversubscription, time slicing, and the performance degradations are very rapid at this point in time. And so let's just try and talk a little bit about that, because and some numbers, because having diagnosed it, you're going to have to get some numbers, and then having diagnosed it, well, what do we do next? We've still got this live system that's oversubscribing. Where do we start managing the process to get it within sensible bounds, and where do we start applying the knife or surgically scaling back certain workloads to stop oversubscription of the system? And this is a data-driven process. One of the other things we also notice is that we very quickly get into a situation when we tell people to oversubscribe, people don't believe us. And I totally understand that, because a lot of the statistics that we use to determine CPU utilization in fact lie. And this is something that we've really hit on about the last 3 or 4 years with the advent of thread-based CPUs. Unfortunately, majority of operating system monitoring utilities monitor thread utilization, not core utilization, but it's the cores that do the work. Why they've decided to do this, it sounds like a classic product management, oh, let's try and remarket operating systems and make the threads look like virtual CPUs and all these sort of things. And you can see as we get into the world of virtualization, where we have virtual CPUs and we don't actually even understand the number of physical cores, this is going to get more and more complicated as we go along. So let's just get back to some basics. Cores do the work, threads don't do the work. And be ready, you may have a little bit of a shock. We probably hit this situation about once a month, where we have to break some news to some poor client who's basically think they're at about 50% utilization on their hardware, when in fact they're fully redlined. And so, you know, be ready for potentially some bad news on this side of things. But, you know, it's part of our growing, part of our industry is as we move into new CPU architectures, we need to sort of learn how to monitor them, and it just doesn't work like it did 10 years ago. And it's really the advent of threaded architectures that's brought this one on. So what we started to do is we're starting to correlate, and this is what all good engineers do, is they start correlating various statistics and learning which ones to trust, or learning to which ones to basically adapt and figure out, you know, what's the picture we've got. So at the database level, we actually have a lot of statistics. And from your AWR report, you can actually see how much CPU seconds was burnt over your AWR period. But one of the most useful metrics we have, and you can see that down the bottom, is the amount of CPU seconds burnt per second. So if you think seconds per second, it sounds like something we did in maths, differential equations and things. It's basically telling us how many cores are we using per second. Okay. Now on this system that we had over 100 cores, but you can see here we're using over 90. So we're well on the way to oversubscription. We're basically asking us to burn, 92 CPU seconds per second. If that number was far in excess of the number of cores, that would be an indicator of quite literal a lot of oversubscription. And very often we would see a light green stripe on enterprise managers indicating that we were probably competing for CPU and we were in fact time slating. So this is a very good sort of sanity check to look for oversubscription really quickly. But at this point in time, we're thinking it, and at this point in time, the operating system utilities that were being used were managing thread utilization, and we're not reporting such high utilization. The core utilization figures, when they were monitored, did show that, but again, most people don't monitor core utilization until they have to, unfortunately. So you can see that the machine is pretty busy. Now, what we also did was take things a little bit further, because now having got to an oversubscribed state, to stabilize the system, we've got to start taking some load off the system. And where is the most leverage to do that? And something that we sort of discovered, as a technique over the last couple of weeks is that we have the in 11.2. The audit log, where we're actually monitoring each SQL statement and the amount of CPU. Now, I'm not saying this is a recommended technique, but this is basically being an engineer. This was enabled on the database anyway, so we were able to basically unpick this log file and see the CPU that was burnt per SQL statement, and then start running some queries against it. Because we knew where various applications and servers and things came from which different client and app server machines, we could start allocating which resources were chewing up the most CPU on the database machine. So we've got a nice little report there, and what we actually do is we divide through by the total amount of CPU seconds available on the time window that we're actually running the query. So we can actually do that as a percentage of all the CPU seconds. So we're getting an indication of what's going on. But what we end up with as a report is you can see that basically the total number of CPU seconds was very close to the number reported on the AWR report. So that really is starting to reinforce your numbers. It was quite interesting going up at the North Sales validation. They have all these amazing systems to create molds and offsets and cut sales and put things down very precisely. But in the end, before they start things in motion, they still got to take measure out and double check everything. And so this concept of double checking your numbers is something that I think we've all been doing for a long time. But trying to validate your numbers through two separate sources is always a good idea. So here we'd validated the amount of CPU quite nicely. And what we'd actually done on just basic this time window, we'd allocated the CPU that we'd added up by SQL statement, added up to 76% of all the CPU burnt over that time window. And that was just the database CPU. We knew that there were other programs and other processes running on this machine that would have been eating into the CPU. So it was pretty quick. By segmenting it out, you could see that basically the background batch workload was starting to oversubscribe and dominate the machines. And so the first solution was to start backing off on the batch here, such that they weren't oversubscribed on the machine. Now, once we've backed off the batch, the system was starting to run a little smoother. The batch jobs were starting to back up a little bit. However, the system wasn't falling over. At this point in time, it gets a bit more interesting because now we can start getting into doing performance projects in terms of isolating the batch jobs that are inefficient, tuning them, tweaking them, and removing those CPU cycles. But this is a classic sort of, okay, we're oversubscribed, but what do we do next? Well, the next thing we do is the first important thing to stabilize the system is back the workload off. Well, we need data to figure out where to get the most leverage to back the workload off. So find the high load batch was the most important thing. And then once the system is under control, it's back to good old-fashioned real-world performance, hard work, fixing up inefficient programs. Great. You know, the level of correlation was fantastic, and you know, just an interesting piece of work that was put together over a couple of days over the last 2 weeks. Now, the last thing I'd like to cover is we talked about the Real World Performance Challenge. Well, as of the page that you can download the videos to watch them, we now are going to have a link, and I think it's going online today, for you to enter your own performance stories of how you've used real-world performance techniques to improve the performance. And we have a bicycle metaphor this time. We have the rules to submit your entry, and we're looking here really wanting to basically do either quarterly prizes and a series of annual prizes with a view to presenting those prizes at Open World in 2015, and perhaps even providing a platform for you to actually describe the performance work you've done at Open World. And hopefully that's a big enough motivation to be basically share the stage of the Real World Performance Group, showing how you've improved performance. So there's some very just simple forms for you to basically fill in the details of which real world performance techniques, type of system, which utilities and which statistics you use to solve the problem. And what we want you to do is just enter some simple data of the problem and the performance improvement. And then if it looks good, we'll get back to you. There's so many rules about uploading information to Oracle that gets us into all sorts of security problems. So we won't ask you to send in files or any trace files at this point in time. When we see a really good example of real-world performance work, we'll come back and find you. And if you have something like a PowerPoint or a report ready showing it that you can email to us, we'll start a dialogue and get you entered into the contest. So the challenge is out there. You know, the sort of things we're looking for is people who've organized their connections such that they don't overscribe their machine and they make their OLTP systems bulletproof. People who have improved the execution plans by understanding cardinality feed errors on their execution plans by factors of 1,000. People who have rewritten row-by-row programs for set-based techniques and improved performance by thousands. Any of those techniques, if you want to document them, show them and share them, and the benefit you brought to your business, and a great chance to basically promote yourself, promote your organization or your partner organization or consultancy practice as being able to move the needle in terms of performance orders of magnitude. So I wish everyone all the best of luck. I think we're getting up to 5 minutes to go, so I'm pretty much complete here. So I see a few people out there. Are there any questions? Otherwise, of course, if you're listening to this because it's Friday night and you want to go home, or you're in the middle of the night in Asia, please email questions into me, and we want to start getting up a catalogue of events, hopefully which is the best time of day. And, you know, subject matter requests would be great, and just want to hear from everybody and hear people's stories of how they've applied these techniques and made a difference to performance, because ultimately real-world performance, to be a good real-world performance engineer, is taking your analysis, making changes, initiating changes, and then getting into production and getting the benefits. And when you've got them into production and got the benefits, then you have a great story to tell. And that really is a real credit to the engineer that initiates those changes. And I wish everyone the best of luck. All right, I've got a question here in terms of which specific classes cover our real-world performance topics. Well, we have the real-world performance class that is managed by a colleague of mine, John Zimmerman. He'll probably love me for mentioning his name on the web because he'll probably get emailed. which we have a few classes organized over the summer months around the world, and we're filling up with participants. You know, the important thing is to get yourself on a wait list for that, and we'll try and let you know when the class is coming up. We're doing them pretty much very ad hoc when we can and by request. And the real challenge we have is that we're performance engineers, we're not education organizers. If you can take the initiative and arrange locations and lecture facilities and the facilities to run the class, we can put the class on. So it's, if you have a company and, you know, we usually look for a minimum of 35 students and they want to learn, and you can organize the facilities for 35 students, it's very easy for us to give you the class. So to challenge you out with user groups, partner organizations, and things like that, if you can organize the students, we can run the classes. Also, early 2015, we'll be back in Europe doing the Real World Performance Day like we did in Europe. And we're trying to liaise with North American and Asia Pacific user groups to do the Real World Performance Day. That's when myself, Tom Kite, and Graham present for a day on all these topics and have a little bit of fun with it. So other than that, we have the online videos, and again, we've had some fantastic feedback on the videos and suggestions, and we're just going to keep on tweaking them and modifying the appendix and stuff on the videos based on people's feedback and requests. But I will have one caveat. In terms of the system that we use to demonstrate all these performance things, we can't give you the code. One, I don't want to support it, and two, that is, it's quite a convoluted bit of code that has been designed deliberately to demonstrate performance problems. So there's a lot of magic numbers because we know at which point the machines break, and that's the purpose behind the demos, is to show a machine yielding and breaking in slow motion. And those that watch the huge page demo will see that happen right in front of you. Great questions. Thanks very much. Any more questions? At this point in time, with no more questions, I think it's time to call it a day, and we'll speak later. As I say, what we will do is work up a new agenda in terms of more sessions moving forward. We're trying to do them once a month, but your feedback is great in terms of what time of day or what time of week would be fantastic. As I say, we've just arrived at 8 a.m. Pacific time on Fridays for this session, but we're pretty open-minded for other times. So your feedback is great. We can make these events, and you know what I'd like to do is make these sessions very conversational and very frank of what's current. Okay, thanks very much. All right, everybody have a fantastic weekend. Summer is there. Get out, and hopefully you're going to see the outside world and not be having too much exciting time fixing slow performance on systems and problems. All right, thank you very much.